So in y equals, I could use what I see here. So I recommend insert an x and then a minus and put the top in parentheses. Go to the end. Maybe that's more difficult to go to the end and then type in everything. Close the parenthesis and divide by parentheses. 5x to the fourth minus 12x cubed plus 3x squared minus 2x, is it? And minus 1, correct? Okay. And minus 1. Then close the parenthesis.
Could you flip over to the calculator screen? You're fine. I know how to enter it, I just didn't know what to do after that.
Okay.
Yeah, I don't know how to get,
Yeah, I don't remember how to
when you
get
go
it.
to the normal calculator part, how to get that Y1 to come out.
Oh, yeah. So now we have this in. We have x minus blah, blah, blah over f prime. Yes? We have this in the calculator?
Yeah, written down.
I have it in the calculator.
Well, he has it in the calculator.
Okay, but do you know how to put it in?
Yeah, yeah.
Okay.
He knows.
So now I go to, get out of there, and I go to variables, scroll to the right where it says y variables. I press enter, and I recall y1 because everything I put in is in y1. Press enter, and then in parentheses I put my first value, which is x0, -2. And then I press enter. All I have to do is go to second and entry. But instead of -2, now I want the previous answer. So the previous answer, and close the parenthesis and delete anything else. And now I can continue with this forever, because it will give me closer and closer. So the first one with y1 of -2 is this. y1 of all this, of the previous answer, is this. y1 of the previous answer, which is this, is this. y1 of the previous answer is this, and I guess I have to continue. But I have to write them down now because everyone needs to see those. So I used x0 to be -2. And then x1 turned out to be -1.560209. And then x2 turned out to be -1.256593. And then x3 -1.09388812. x4 -1.047823. And then I continue. Just press enter all the time. Okay, and I got it. So since these 4 digits now repeat, this is the last one I'm going to write.
And it won't go any farther than that last one. That's-
Right. I don't need to because we decided 4 digits anyway. So, and remember, this is the best tool now. You can solve any equation on the planet. Because you know calculus and you know Newton's method. We don't know how to calculate all this in algebra. We can solve equations that are linear, quadratic, absolute value, cubic if they're factorable, 4th degree if they're factorable. But now you can solve any equation you want. Okay, going back, are we going to graph a function or? Yes?
Yes.
Okay, so let's choose a function to graph. And then, of course, L'Hopital's rule, it's part of the deal. Okay, let's graph number 11.
So what page?
317. And y equals x minus x squared divided by 2 minus 3x plus x squared. Do you want to work on this for a minute, or you want us to go ahead?
Yeah, let's just do it.
So we're gonna find the main first.
Yes. Can anyone give us the domain of this function?
You start, find the domain. Not the domain, but the denominator.
Are we in agreement with this? All I did was just algebra by factoring, right? I cannot touch the function. I cannot simplify anything before I state how many restrictions? 2. X cannot equal. Now I'm allowed to simplify it. So the simplified form of this is x over x minus 2. Which of these two, or both, will be vertical asymptotes, 1 and 2? 1 will be a hole in the graph, and x equals 2 will be a vertical asymptote. Please remember that. It's still a restriction for x, but since the factor goes away, it will be a hole in the graph. The only vertical asymptote is at 2. So therefore, I start my chart. Since the domain is not 1 and 2, I have to show that. So I need this, I need this, I need this, and this, and this, and this, and this. So let's start with this. How do I get this? Yes, the limit as x approaches negative infinity from negative x over x minus 2. What is the answer?
1.
With minus in front.
Yeah, sorry, -1.
Yes, because when you differentiate, it's infinity over infinity. The top is 1 and the bottom is 1, but with minus in front. So it's -1. What about limit when x approaches infinity?
Should have said that.
Of course. Good. What about f of 0? Good. So that is the x-intercept and the y-intercept. Good. What about limit as x approaches 1 from the left from negative x over x minus 2? And what about the limit as x approaches 1 from the right of negative x over x minus 2? And then finally limit as x approaches 2 from the left, and limit as x approaches 2 from the right from negative x over x minus 2. What about the limit as x approaches 1 from the left? So the top is 1, right? The bottom is -1, but there is a minus in front, so it's 1. 1 from the right is 1. The top is the bottom is -1 with minus in front is 1. Very good. As you see, that's why this is not a vertical asymptote. Good. So now as x approaches 2 from the left. 2 from the left, I know it's an infinity. In both cases, it must be x must be a vertical, x equals 2 must be a vertical asymptote. But what is the sign here? 2 from the left, 1.9. Denominator negative, numerator negative, so the sign positive. 2.1, denominator positive, numerator negative, sign negative. So then on this side I have positive infinity, on this side I have negative infinity. I'm done with the function. There's nothing else I can find out. Ready to continue?
Yes.
Okay, so then I have to find f prime. I differentiate the top, leave the negative in front, forget about it for a moment. The top prime is 1, x minus 2 minus the top times the bottom prime, which is 1, over x minus 2 squared. These two go away with minus in front. This is 2 over x minus 2 squared. When is this 0? Never. What is its sign? Always. Good. I'm done. No critical numbers, no max min. The function is always increasing on all its domain. Let's check. Make sure that these two work well together. If they don't, there is a mistake. From -1 to 0, is the function increasing? Good. Is it increasing from 0 to 1? Good. Is it increasing from 1 to infinity? Is it increasing from negative infinity to -1? Good. So far, so good. Now I have to find this. So here is the function. I will change it into 2 times x minus 2 to -2. And when I differentiate, I get -4 x minus 2 to the third times the inner function prime, which is 1. So this negative, I'm sorry. And -4 divided by x minus 2 to the third. Now this is a different story about the sign. This is never 0, right? But the sign, I have to be careful. I will change it into -4 over x minus 2 squared times x minus 2. Why? Because I don't need this. What is the sign of all this? Positive. So the sign is really given by negative x minus 2 with negative in front. So x minus 2 with negative in front is this, which is a linear function with a negative slope. What is the sign of a linear function with a negative slope? From
Infinity to
from positive to, right. So from positive till it's 2, positive all the way till 2, and negative afterwards, which means this and this. And no inflection point, because the function is undefined here, and the second derivative is not 0. That's all I need. Just this. I'm done. I don't need anything else. So then, at 2, a vertical asymptote. And now I read my chart.
and -1 is horizontal.
Yes, and -1. Thank you very much. Horizontal asymptote. I forgot to write it. See? Good. So now I'm reading my chart. It says, okay, 0, 0. So it says, from approaching, when x approaches negative infinity, y is approaching -1. It's increasing, crossing at 0, 0, going to 1, from negative 1, crossing at 0, 0, increasing at 1, comma 1. From 1, comma 1, increasing towards infinity on the left-hand side of the asymptote. On the other side, it's coming from negative infinity, and I forgot to say it's opening up. So it's coming from negative infinity, opening down, increasing to negative 1. And this is our function f of x, x minus x squared over 2 minus 3x plus x squared. Any questions? Any questions on this?
Can we do one that has the max?
Yes. Yes. Okay. Let's look at number 6. Any questions on this problem? Number 6. Y equals x to the 5th minus 5x. So let's start working on this. Should I still wait or? Can we start? Obviously, it's a polynomial function, so domain is all real numbers. No questions there, right? Good. So all I can ask here for the function is the x and y intercepts and the limits. There's nothing else I can get from the function. So first of all, f of 0 I know is 0. Now the function could be 0 in other ways. So I have x to the 5th minus 5x equals 0. I factor out x, and I get x to the 4th minus 5, which I have to solve, right? So there are two options here for now, x equals 0 and x to the 4th minus 5 equals 0. I could factor this into x squared plus the square root of 5 and x squared minus the square root of 5. This will never have solutions because it's always positive, but this one will have two solutions. So x squared equals the square root of 5. I take the square root again, and I get x equals plus or minus the 4th root of 5. So I have to put this in the calculator, in my chart, I'm sorry. So I put 0, so I have negative the 4th root of 5 and positive the 4th root of 5. And now the limit. This is a 5th degree function. This has the weight. This is very small in infinities. So when x approaches negative infinity, this will be negative infinity. When x approaches infinity, this will be infinity. Now I have to try to find, I have to define the first derivative and critical numbers. And we'll see if they exist, whatever, in a moment. So f prime of x is 5x to the 4th minus 5. Of course, I will factor out 5 and I get x to the 4th minus 1, and I will continue with x squared plus 1 and x squared minus 1, and I will continue with 5, x squared plus 1 and x minus 1 and x plus 1. When I set the derivative equal to 0, I will only have two options, however, x equals 1 and x equals negative 1, because this is always positive. So now I'm looking at the 4th root of 5. I want to see how much that is. So in the graphing calculator, 5 raised to 1/4. 5 raised to 1/4 is 1.49. So negative 1 and positive 1 will be between these two. So negative 1, positive 1. Oh. So negative 1 and positive 1, 0 and 0. So now I'm looking at this derivative. This will always be positive, will not bother me. But this, the product, this is a quadratic function opening up x squared minus 1, right? So in between solutions is below the x-axis. Outside of the solutions is above the x-axis. Or you can plug in a number. So this is definitely negative and this is positive. I have to find this number here and I have to find this number here. So when I plug in negative 1, this is negative 1 plus 5, which is 4. When I plug in 1 is 1 minus 5, which is negative 4. I have to make sure that these two work together. Otherwise, there is a mistake somewhere. So here's my question to you. Now, from negative infinity to 0, is this function increasing? From 0 to 4, is it increasing? From 4 to 0, is it decreasing? From 0 to negative 4, is it decreasing? From negative 4 to 0, is it increasing? From 0 to infinity, is it increasing? It appears that all is in order. Now, what type of point is this? Yes. Is it max or is it min? So it's positive, it's going up, and then it goes down. It's going up to it, and then down from it. Positive and negative. So it's a local max. What about 1 comma negative 4? It's coming down and then up. So it's local minimum. Good. Now I have to determine the second derivative. Of course, I'm not going to look at this. Oh, no. I'm going to look at this or at this. I'm going to leave the 5 outside because it's a constant times a function. So when I differentiate again, the second derivative, 5 is outside. I differentiate the inside. It's 4x to the third, which is 20x to the third. So this is 0 only when x is 0. Now I study the sign. Here's how I study the sign. 20x squared times x. Why? Because I'm not going to plug in anything in that. I refuse. It's always positive. So only x dictates. So it's positive to the right and negative to the left of 0. What type of point is 0, comma 0? Inflection point. The second derivative is 0, and the sign of the second derivative is opposite, left and right. So down and up. That's all I need. And what did I get for that? It's 1.5. So I'm gonna approximate this 1.5. It's not, but it's roughly. And this negative 1.5. And the only thing that I need now, because I see so much symmetry here, I have to check symmetry. I have to find f of negative x. F of negative x is negative x to the fifth plus 5x, which is indeed the opposite of f of x. What type of function is this in which f of negative x equals the opposite of f of x? Odd, which means symmetric with respect to the origin. Symmetric with respect to the origin. All I care about is nothing but my chart. Ready? I have to plot these points. What points? Negative 1.50. Negative 1, comma 4. Zero, comma 0. 1, comma negative 4. And 1, comma 5, 1.5, comma 0. Ready? So, from negative infinity, opening downward is increasing to this point. From negative infinity, increasing to this point, opening downward. It continues to increase to the local max of negative 1, 4. When starts, because it's maximum, local maximum starts coming down, still opening downward, but decreasing to 0, 0. Where I know it has an inflection point, because all of a sudden it starts opening upward, and it's further decreasing to this point. But now it's increasing from this local minimum. It's increasing to this point, 1, comma 50, and increasing further to infinity. Bless you. So this is our f of x, x to the fifth minus 5x. Any questions on this?
And when we're graphing, it'll have a diagonal asymptote if there's one power difference between the...
Yes, a slant or oblique asymptote, yes.
Oh, slant.
So that's the same thing. Only when you're looking at a rational function, nothing else, just rational function, and the top is exactly what you said, 1 degree higher, a polynomial with 1 degree higher than the degree of the polynomial
So it has to be 1 degree higher.
1 degree higher. If it's 2, when I divide,
Well,
the
I was
answer
just
is not
thinking
going to
if
be a
it's-
line.
So it couldn't be x squared over x to the third. It would have
Yes,
to be
but
x to
then
the third.
the horizontal asymptote is 0, and there is no slant. So for a function with a higher degree at the top by 1 unit higher than the degree at the bottom, that function does not have a horizontal asymptote. Only 2 types of rational functions have a horizontal asymptote. One with a higher degree in the denominator, this is always 0, and one with the same degree of a same degree. These are the only 2 types that have horizontal asymptotes. If it's a degree higher at the top versus the bottom,
You don't have a
slant. But if it's degree difference 2 or more, no horizontal, no slant. This is the la-la land. We can't get there. It's too difficult. Any questions? Any questions?